Good morning. We'll move to the last module and the sixth one, Geotechnical Engineering 2. Now for you to just brush up what we have been discussing in the previous 5 modules, we started off with the stresses in soil due to the loaded areas. In the first module, we discussed what the Boussinesq equation is and the solution to different numerical problems regarding the vertical stress beneath the loaded areas, the circular areas, the rectangular areas, the strip load, etc. And in the second module, we discussed lateral earth pressure at rest, active and passive cases. We briefly discussed what Rankine's and the Coulomb's earth pressure theories are, and we discussed the geotechnical design of a retaining wall under different conditions of surcharge, incline, backfill, water table fluctuations, etc. And in the third module, we had discussed the bearing capacity of shallow foundations, the allowable bearing pressure, the Tezagi's bearing capacity equations, local punching and general shear failures, etc. And the influence of water table was also discussed. And a short description on the differential settlement and how to reduce the differential settlement using preloading and sand rain methods, etc. was also discussed. And in the fourth module, we moved to the combined footing, the rectangular and the trapezoidal. We also discussed the raft foundations in brief. And also we entered the deep foundations. The well foundation in specific was discussed in the fourth module. Fifth module was about the pile foundations, and it included the static method and the dynamic formula to estimate the pile capacity, and also the group efficiency and negative skin friction were also discussed. Now the sixth module it does have 2 parts to be specific. The first part is about site investigation and the second part is about machine foundations. The first part, you have a brief introduction to site investigation, the objectives, the guidelines for choice of spacing and the depth, and a few methods of site investigation, SPT, the standard penetration test, and a procedure and the corrections to that. These are included in the first portion. The second portion is something to do with the machine foundations. Though it's a very deep subject, just the peripheral is explained in KTU syllabus, so it is limited to the mass spring model for undamped free vibrations, the natural frequency, coefficient of uniform elastic compression, and a few methods of vibration isolation. Now, site investigation. As a design engineer inclined in geotechnical engineering, you will have to pay a visit to the site before you arrive at any specific design, the type of foundation, the depth of foundation, the methods of construction, etc. So site investigation is quite important to arrive at the economical and the feasible design. A few objectives of site investigation is listed here: to select the type and the depth of foundation, to determine the bearing capacity of the soil, to estimate the potential settlement, to observe and to find the groundwater table, to select the suitable construction method, to investigate the safety of existing structures, etc. Now, though it's not limited to this, it includes all the points that I've listed here. Now, the first phase of planning the exploration program depends on the type of the structure and the variability of the strata. The type of the structure can be a residential building, it can be a dam, it can be a commercial building of G+5, etc. And also the plan can be irregular or rectangular, etc. So the exploration program depends on the type of the structure and also the variability of the strata, whether you can expect almost uniform nature of soil beneath the earth level that you see, or whether you can expect abrupt variations, whether rock is available at a shallow depth or whether it's expected only at a deeper depth of, let's say, 15 meters, etc. So everything should be included in planning. The economic aspects also governs the program, which means there's a limitation for the fund which can be earmarked for the site exploration and also the foundation. Let's take an example. if you're designing a house or residential building of, let's say, the total cost of let's say 60 lakh. So in such a case, you don't have the luxury of spending about 10 lakhs into the soil, into the substructure. So the economic aspect also comes into picture. But when you are designing something which has a budget which is greater than, let's say, 2 crores rupees, you do have the luxury to spend, let's say, 25 lakhs into the substructure. So the balance act comes into picture when a more detailed the exploration is, the more confident will the design be, which means as you know much better about the soil as an engineering material, you'll be much more confident to design the foundation. And the investment on the exploration should not outweigh the saving in the project cost. And the approximate cost is about 0.1 to 1% of the total project cost. Now, the stages of site investigation includes number 1, reconnaissance, which means you visit the site, you study the maps and decide the programs. Second one is the preliminary exploration, which means you determine the depth, the extent and the thickness of each layers of soil, and also you determine the level of the bedrock. The third one is a detailed exploration, which means you determine the engineering properties of the soil based on the soil that you've collected and the soil that you have carried to the lab, and the properties you are estimating in the laboratory using different tests. So that gives you an idea of the engineering properties of soil using the sample collections, lab testing, etc. So these are briefly the 3 stages or 3 steps of a site investigation. Now, the guidelines for depth of exploration, which means to what depth the soil should be explored for a particular project. And the depth of exploration depends on the degree of variation of the subsurface profile and also the influence zone of the structure plan. We had discussed what the influence zone means, the isobars, the pressure bubble, etc. So you are actually interested to arrive at the properties of the soil which is within the influence zone. And the soil which is within the influence zone is predominantly the one that governs the load carrying capacity. So the depth of exploration should at least be equal to the depth at which the vertical stress is 20% of the load intensity. Again, these are just the guidelines. The decision solely rests on the engineer at site and also at the design office. So everything includes and involves an engineering judgment. It's nothing like a codal practice that we follow, but still it involves engineering judgment, and the design engineer and the site engineer should have the actual practical knowledge on how to carry up the depth of exploration. Now, the guidelines for depth of exploration, like I said, there are rough guidelines given by standard textbooks and codes, a few of which is included in this slide. The depth should be equal to 1.5 times the width for a square footing below it. So when you have a square footing, you should go 1.5 times breadth below it, which means, for example, if you have a square footing of 2 meter width, you should go 3 meter below that footing width, is equal to 1.5 times the width for strip footing also below it, is equal to 1.5 times the width of a pile group for end bearing piles below it, as you can see in this figure, is equal to 1.5 times the width from the lower third portion for pile groups of friction piles, is equal to 1.5 times the base width for retaining walls, etc., etc. So these are just the standard guidelines that will help you to choose the depth of exploration, or in short, to what depth you need to carry out the soil exploration. For multi-story building, this is just again a thumb rule. Depth of exploration D is equal to C into S raised to 0.7, where C is a constant, taken equal to 3 for light or narrow buildings and 6 for heavy or wide buildings, and S is the number of stories. Again, this is just a guideline, and for foundations resting on rock, it should penetrate the rock for about 3 meters, though in practice we may not follow it strictly because it may not be too economical. For roads, D is equal to 2 meter or equal to the height of the fill, whichever is greater. For gravity dams, depth is equal to twice the dam height, etc., etc. So these are the standard guidelines that we follow. Now, like the depth of exploration, we need to arrive at the spacing of exploration, which means the number of boreholes taken at a particular site and the spacing between these boreholes. Again, it depends on the variation of the strata in the horizontal direction. And for small buildings, just one borehole will be sufficient at the center of the plot. Residential buildings are example. And for buildings which cover a planned area of 0.4 hectares, one borehole at the center and 4 boreholes at the corners, making 5 boreholes total, is suggested. For multi-story buildings, boreholes at all corners and at important locations at say 20 meter spacing. And in case of highways, you take the boreholes at 150 to 300 meter spacing along the alignment of the highways. And for dams and other hydraulic structures, you take 40 to 80 meter spacing for boreholes. Again, these are all just guidelines. Everything is under the control and under the engineering judgment of the design engineer and the site engineer, and everything depends on the site conditions.